In this screencast, I'm going to take an introductory look at material and labor variances. The price or rate variance is designed to determine the impact on total costs of the unit price in either materials or labor compared to the expected price per unit for materials or labor. The delta price then is the actual cost per unit minus the expected cost per unit, but this is not the same as the price variance. The quantity variance looks at the impact on the usage of materials or labor on expected costs. The delta quantity is defined as the actual amount of material or labor used relative to the expected amount of materials or labor used. And once again, the change in the quantity is not the same as the quantity or efficiency variance. The direct materials price variance measures the input price of materials relative to the expected input price. We calculate this by taking the delta Q times the number of units of materials that were purchased or, in some cases, used in the production process. The direct labor rate variance is the change in price, actual labor rate minus the expected labor rate times the number of labor hours used in production. The direct materials quantity variance is the actual quantity of materials used per unit of output minus the expected quantity of materials used per unit of output. Take that difference and multiply it by the total number of units of materials that were supposed to have been used given the output. This can be a somewhat tricky calculation, and we will go through an example in a few moments. The labor efficiency variance is the actual labor hours per unit of output minus the expected labor hours per unit of output times the amount of labor hours that should have been used given the output produced. Here is a numerical example for calculating the materials variances. Notice that we have 6,150 actual cookies produced, whereas the static budget called for 6,000 cookies to be produced. The total amount of materials used was 1,968 pounds as opposed to 1,800 pounds, and the cost per pound for materials was $3.10, while the budget had the cost per pound at $3.25. On the next slide, I'll show you how to calculate the variances. On this slide, I'm going to set up the template that I like to use for calculating materials variances. I have three columns: actual, an intermediate column, and a flexible budget column. The actual column has the actual quantity of materials times the actual price per unit of materials, and this gives us the total actual cost of materials used. The intermediate column has the actual quantity times the budgeted price, and the flexible budget column has the flexible budget quantity, which is different than the static budget quantity, times the budgeted price. To calculate the price variance, we take the price variance is equal to column 1 minus column 2. And this is the same as calculation as I showed on an earlier slide, because if you think about it, the quantities are the same between columns 1 and 2, so that's the actual quantity, and the delta is the difference between the actual price and the budgeted price. If we compare the product from column 1 and we subtract the product from column 2, so we have $6,101 minus $6,396, we get a negative $295.20. This is a favorable price variance since the actual price of materials, $3.10, was less than the budgeted price of materials, $3.25. To calculate column 3, we need to understand where the 1,845 comes from. Well, that calculation is shown below. There were 6,150 cookies made, and the number of pounds per cookie based on the budget is 0.3 pounds per cookie. So the total number of pounds of materials that should have been used is 1,845 pounds. So we take the 1,845 pounds, multiply it by the budgeted price of $3.25, and we end up with $5,996. To get the quantity variance, take the intermediate column product, $63.96, subtract the flexible budget product, $59.96, and now you see we have an unfavorable quantity variance of $399.75. And the reason for this is because the actual pounds of materials, 1,968 pounds, was greater than what the budget would allow for a production of 6,150 cookies. And that difference is reflected in the unfavorable quantity variance. Here is the data we can use for labor hour to calculate variances. We have a column of actual labor hour outcomes, and we have the static budget based on a plan to make 6,000 cookies. As you can see, the total labor costs, $5,919, are greater than the static budget of $4,320. Let's run through the labor variance. We start off with the actual quantity, where the actual labor hours of 307.5 is multiplied by the actual labor rate, $19.25, ending up with actual labor costs of $59.19. The intermediate column uses the actual number of labor hours times the budgeted labor rate of $18 per hour, and we get $5,535. That's column 2. If we subtract column 2 from column 1, so 1 minus 2, we get an unfavorable price variance of $384. To calculate column 3, the flexible budget, we need to take the number of cookies times the amount of labor per cookie. Given that 6,150 cookies were made, 246 labor hours should have been used. 246 times 18 is 4428, and if we take column 2 and compare that with column 3, so column 2 minus column 3, we see an unfavorable efficiency variance of $1,107.